to show you how we can build a multi-modal RAG kind of pipeline, right? So essentially, RAG is a retrieval augmented generation which enhance the response of the LLM model, right? And traditional RAG which can only process the text, but with the multi-mode RAG we can process text as well as the images, right? And in this demo, I want to download the Wikipedia data of related to the vehicle, right, which will have text and images, right, and I will store those data into the quadrant vector DB, right, for the semantic search, and then I will use those the context from the similarity search from the vector DB and pass that to the GPT-4 model, right? So these are the high level steps which we will perform. Right? So we will set up and install the prerequisites, right, in the Python, and then we will prepare the environment where we will create the folders to store the images, right, and then we will collect the data and uh, from the Wikipedia, right, and then we will store those data into the folders, and then we will build a multi-modal index where actually we'll use this quadrant DB, and then we will store the text and images as a vector in the this quadrant DB vector DB, and then we will implement the multi-modal retrieval, right, where we will ask query or question, right, and then the this multi-modal will respond in the with the text and images, right, and then finally we'll use the multimodal RAG query where we will integrate this retrieval system with the GPT-4 model to synthesize the response, right? So this is how the multimodal works, right? So essentially these are the four steps. First we'll do the indexing, right, where we will store text and images in the vector DB, right? Then we'll do the retrieval, right, where it will retrieve the response based on the relevancy of the text and images, right, and then we will do the augmentation, right, where we'll pass this retrieved information to the LLM model, and then finally we'll use the LLM to generate the response based on the augmented input, right? So let's start with the setup and installation, and here actually I'm using the llama index, right, and llama is actually index is it's a framework which help to build this LLM kind of application, right? So we are installing this llama index embedding click mm, from package, right? That's the first step. Then we also need to install some other modules or packages. So these are the different module and packages we have to install, like Matlob plotlib for displaying the images, quadrant client for vector DB, right? And then some other Llama modules, right? So after installing these modules, next thing is actually we have to prepare the environment, right? And to prepare the environment, first thing what we need to do is we need to get the open API key, right? And I have stored this open API key in the users, so I'm just retrieving this key and assigning to this environment variable, right? And I will use this environment variable in the following code, right? So the next thing is actually we have to create the directories for storing the images and text. So here this is the piece of code where I'm creating the folders for images and the text, right? And then here I'm loading the images, right? And copying those images of Tesla and other vehicle into these folders. Now we want to understand how these images looks which we downloaded, right? So I'm using this matplotlib library to display these images, right? So this is the piece of code I have wrote to display the images, right? So this will display the downloaded images and you can see the images here, right? And then after downloading these images, now the next step is we want to extract the description from these images, right? And for that actually I'm using the GPT-4o model, right? So which will extract the text from the images, right? So as you can see here, first what I'm doing, I'm copying, getting this images, right, which is downloaded in the local folder here, and then I'm invoking this model, OpenAI multi-modal, right? So I'm defining the model name, right? And then the API key, and then the max token size, right? And then I'm I'm calling this OpenAI complete method, right? Where I'm passing this prompt, right? Where I'm telling model to generate a detailed text description for each images, and then I'm passing the all images as a parameter, right? So after that actually it will return the response, and as you can see we are displaying the response here, and it extracted all the information description from these images, right? As you can see here, for image one this is this description, right? So and then for image 2 this is the description, for image 3, right? So for all four images it retrieved the description, right? So we were able to successfully get the description using the GPT-4o model, right? Now the next step is data collection and preparation, right? And in this section, actually, we will collect the text and images from the Wikipedia and other sources, right? So I have created, we have this method here, which will get the data from the Wikipedia, right? So I'm calling this API, Wikipedia API, and then passing the query, right? And it will return the text as well as the images, right? Which will which this method will return, right? And then these are the different titles which I want to download. For that I want to download the text and images, right? So I am defining the all the titles like Tesla, all the models, BMW, right? And then actually I'm using this title to make to fetch the text and images, right? So this is the piece of code which will make a API code, right? And then here I'm getting the pages which is nothing but the Wikipedia text. I'm putting this and I'm writing to this file, right? So I'm writing this as a file, right? And then actually next thing is, for this title we also need to get the image, right? So I'm calling this method here which I showed earlier, right? I'm passing the title and it will download the images, the URL, and here actually we are getting the images, right? We are downloading the images, right? And then so with that actually our data collection has been completed, right? So we collected all the text and images from the Wikipedia of these vehicles, right? Now the next step is we have to build a multimodal index, right? So we want to leverage the this quadrant DB, right? To store these text and images for the semantics search, right? So as you can see, these are the classes I have imported, like multimodal vector store index and then quadrant vector store, right? And then first what I'm doing here is I'm instancing the quadrant model, right, client, right? And then I'm creating the two collection, one for text, one for images, and then I'm just assigning these collections instance to this store context, right? And then I'm loading the all the data from this local storage, right? And then I'm passing these the content like text and images, and then this storage context instance to create a multimodal index, right? So with this actually it will store the text and images inside the this quadrant vector DB, right? Now now we have completed all the indexing part. Now it comes to the retrieval part, multimodal retrieval, right? So in this actually what we will do is we will ask the query to this multimodal vector DB, right? And then actually we'll get a response as a text and images, right? So as you can see, I'm defining the retriever, right? Where I'm telling, okay, I need only the top three text, top three images, right? I'm just looking for the top three because it may have more data. So I'm just looking only interested only for the top three, right? And then actually I have created this method here, right, where actually I'm passing this query, right, and then it will retrieve the data, right, and then in the response it may have images and the text, so I'm just appending these images to this collection, and then I'm displaying the text on the UI, right, and then here I'm displaying all the collected images, right. So as you can see here, I'm asking the question to this function or this model like vector DB, what is the base electric sedan, right? And you can see it responded with this top three result, right? And each node, each result has a similarity score, right? And then the text information, right? And it also has a node ID. So it written all those top three result, and along with that actually it also written the images, right. So essentially it did the semantic search, uh, and then it retrieved both the text as well as the images, right. Now the final step is we want to try is actually we want to do the multi model RAG query, right. So here actually along with the vector search or the information retrieval, we also want to leverage the GPT-O model, right, to synthesize or enhance the response, right. So as you can see here, first what I'm doing here is I'm building a prompt, right, where I'm telling model that this is my context information. I'm passing the context whatever the information retrieved from the vector DB, and then I'm telling instructing the model that given the context information and not a prior knowledge, don't use the prior knowledge, right, whatever the context information I'm passing here, use that and answer the query, and then I'm passing the query also. So essentially I'm passing here two things, one is the query and then one is another is the context, right. And then I'm creating, I have created this multimodal method, right. And in this multimodal RAG query method, basically I'm passing this query, and it will go to retrieve the information from the vector DB, and then it will make a call to the GPT-O model. And then first I'm displaying the GPT-O model response, right? And then I'm also displaying the source information, which is from the vector DB, and then I'm displaying the images. So as you can see, how nicely it returned the answer, right, for this. So I'm asking the query here the compare the design feature of the Tesla Model S and Rivian R1, and it provided the summary for Tesla Rivian, right, and then it has some key information about this both the cars, right, and then as a source which is from the vector DB display the information, the original source information, and then the images, relevant images for this particular question, right. Thank you for watching this video.